We're going to use these circles to work with some radian measures. So the first thing I want to do is take my circle and I want to divide it into, we'll start with, let's start with 8 equal sections. Now when I divide that into 8 equal sections, the whole circle is divided into 8 sections, so each section represents 1/8 of the circle. That's not really what I'm interested in. What I'm interested in is half of the circle, and so I'm going to start here at 0 degrees, and if I go halfway around, all the way around the circle is 2 pi, so halfway around the circle is going to be pi. So I'm taking this pi right here, which is really, looks more like a taco or a calzone. I'm taking that pi and I'm dividing it into 1, 2, 3, 4 sections. So ignore these little fractions right here. Just mark them out if you need to. Ignore them, don't pay any attention to them. So what I have is my pi divided into 4 sections. This first section then is a pi over 4 section. If I add another pi over 4 section, that makes 2 pi over 4, but that reduces to pi over 2. And then if I add another pi over 4 section, I'm at 3 pi over 4. Okay. Now I can continue beyond pi. Move my circle back up, or my semicircle back up. And I can keep counting. This lower half of the circle is also represented by pi. So if I keep counting around the circle, 3 pi over 4 is here. If I get to 4 pi over 4, that reduces to pi. So this next section, adding another pi over 4, is going to be 5 pi over 4. Then 6 pi over 4, which reduces to 3 pi over 2. And then 7 pi over 4. If I get to 8 pi over 4, then I have all 8 pieces of the circle. 8 pi over 4 reduces to 2 pi, so I'm right back at the beginning at 2 pi. So 0 and 2 pi are coterminal angles. They end in exactly the same place. Let's go to our next circle, and this time we'll divide this circle into 6 sections. If my whole circle is divided into 6 sections, then the top half of the circle from 0 to pi is divided into 3 sections. So ignore the 1/6 all the way around. That's how much it is of the circle, but I'm interested in what part of pi is it. So this first section right here is a pi over 3 angle. If I add another pi over 3 section, I add another angle to that, then that's a 2 pi over 3. 3 pi over 3 reduces to pi, then I have 4 pi over 3, and 5 pi over 3, and 6 pi over 3 reduces to 0, where again I have that coterminal angle. I want to subdivide my next circle into 12 pieces. And if I do that, then my 0 to pi section is divided into 6 sections. So each of these little segments represents a central angle of pi over 6. This pi divided is the fraction bar, into 6 pieces. So that's 1/6 of the pi. This would be 2/6 of the pi, or 2 pi over 6. Now that reduces to pi over 3, and that belongs on this circle right here. So I don't want to include it here, but I do have to count it. If I go here and add another pi over 6 section, that's 3 pi over 6, which reduces to pi over 2, and I've included that on this circle here. If I keep counting, then this is 4 pi over 6, which will reduce, so I'm not going to write it, and this is 5 pi over 6. 5 pi over 6 does not reduce, so I want to include it on this circle. 6 pi over 6 reduces to pi, then we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and finally 11 pi over 6 right here. One more pi over 6 takes us to 12 pi over 6, which reduces to 2 pi. So let's review reference angles just a little bit. If I'm on this circle right here, and I have this angle measure of pi over 6. Now I've written it out here, but really that's that central angle right there, pi over 6. That's in quadrant 1. It's a positive angle. It's acute. and it's the reference angle in quadrant 1. Pi over 6 is also the reference angle for this 5 pi over 6. So my obtuse angle is this one right here, but the reference angle for 5 pi over 6 is this little angle, and that is pi over 6. So if we're in radian mode, it's really easy to read the reference angle right off of that exact radian measure. So in quadrant 3, my reference angle is pi over 6 again. Right there, you can see it on the angle measure, but it's the 7 that tells me this is all the way around in quadrant 3. So the pi over 6 gives you the reference angle, the 7 places you in the correct quadrant, and both of those are going to be necessary for evaluating trig values. Now let's take each of these circles and let's combine them onto one and see if we get something that looks familiar. I'll take my pi over 3 and put it on top of the pi over 6. And then take my pi over 4 and put it down on top of there. And then let's group this and make the whole thing bigger and see what it looks like. Does this look familiar to you? Ignore all of the squiggles in the middle. And hopefully what you're recognizing is that this looks a lot like the unit circle that we have built on your paper plate. The angles pi over 6, pi over 4, and pi over 3 are special angles in quadrant 1. They correspond to the 30 degrees, the 45 degrees, and the 60 degrees that we've already talked about. Of course, 0 and pi over 2 are your quadrantal angles to quadrant 1. And then those same reference angles occur all the way around the circle. In quadrant 2, it's clear to see what the reference angles are: pi over 3, pi over 4, pi over 6. And it's the 2, the 3, and the 5 that place those in quadrant 2. But we don't have to do the subtraction that we had to do when we were in degree measure, and these were 210, 135, and 150, not 210, 120, 135, and 150. So in a lot of ways, even though radians are new to you, they are much easier to work with than degrees. And so I encourage you to use radian measure and not convert unless it specifically tells you to convert or you have a good reason to. Let's look at how we would use some of these values. We can evaluate trig functions. For instance, tangent 2 pi over 3, it's easy to see that our reference angle here is going to be pi over 3. So we fold down our pi over 3 angle on your hand. You're using your hand trick to get the value. And then remember that tangent's on the back of your hand. So we're looking at square root of 3 over square root of 1. So that's the value of tangent pi over 3. Now remember, the 2 places that angle in a particular quadrant. So if I divide my pi, which is from here to here, into 3 pieces, then there's the first piece. Here's the second piece, and then the third piece would end at 3 pi over 3. So it would end at pi. So this is 2 pi over 3 because it's 2 pieces of pi over 3. And that lands me in quadrant 2. If you remember that all students take calculus, then you can see only the sine is positive, sine and cosecant is positive in quadrant 2, which means that our tangent has got to have a negative value. So there are 2 pieces you're looking for: the value itself, which comes from the reference angle, and then the sign, whether it's positive or negative, coming from which quadrant it's in, and it's this number right here that tells you what quadrant that's in. Let's look at sine 3 pi over 2. My reference angle is pi over 2. You can use your hand trick for that, but pi over 2 is a quadrantal angle. If I divide my pi into 2 pieces, then pi over 2 halfway would be right there. It's much easier to just use the ordered pair on the unit circle to evaluate this. That ordered pair is 0, 1, and sine is the y value, so that's going to equal 1. Except that that's my reference angle, and I want 3 pi over 2. So really I should sketch this down here, 3 pi over 2. And that ordered pair is 0, negative 1, so I need the negative. Let's look at the third example. We have cosine negative 4 pi over 3. Remember what the negative on the angle does? It just says rotate clockwise instead of counterclockwise. So that's going to put us in the right quadrant if we rotate in the right direction. Our reference angle here is pi over 3, so we could go ahead and get the value from cosine pi over 3 using our hand trick. Pi over 3 is the reference angle, cosine is on top, so I have square root of 1 over 2. So 1/2 is the value, but then I want to rotate negative 4, so rotate in the clockwise direction. My pi is divided into 3 equal pieces. Here's 1, 2, and here's the third piece. And then I've got to go beyond 3 pieces because I'm looking at 4, so I need one more piece right there. That would be negative 4 pi over 3, which puts me in quadrant 2. All students take calculus, so cosine is going to be negative, only sine is positive, and cosecant is positive in quadrant 2. So this cosine has to have a negative value.